pair of Zener diodes, each with a forward drop of 0.7 and the Zener diode voltage of 4.7 volts is connected as shown in the figure. The input voltage is a sinusoidal function, that is 10 sine of 2t. The peak to peak output voltage is, see, if we indicate two diodes D1 and D2, when Vs is the positive half cycle, then D2 is going to conduct whose forward drop is 0.7, hence D1 is not going to be reverse breakdown, hence the output voltage is towards the positive peak side it is plus 0.7, and the negative half cycle of the Vs, the D1 is going to conduct whose forward drop is now 0.7, hence D2 is not going to be in breakdown region, hence negative peak side is going to be minus 0.7, hence peak to peak voltage is going to be 1.4 volts, hence option C is correct. It's represented as 10101010 using 8 bits in sign magnitude representation. The decimal number represented as, we know that in sign magnitude representation, if it is an n bit number, the nth bit, that is MSB, is a sign bit, that is 1 for negative number, 0 for positive number. Remaining n minus 1 bits in the n bit representation represents the magnitude. So for a given number which is a 8 bit number, if we calculate the magnitude, that is MSB bit is 1, means the number which we are going to get is a negative number. If we calculate the magnitude, that is 10101010. So in magnitude calculation we should not use the MSB bit, but the remaining bits we can calculate for the magnitude. That is, this is the 0 position, 1 2 3 4 5 6 7. So negative 32 plus 8 plus 2, which is minus 42, hence option A is correct. Which of the following statement is correct? Here static 1 hazard may occur in 2-level AND/OR gate network, and the statement B, static 0 hazard may occur in 2-level AND/OR network. Statement C, that is dynamic hazard may occur in 2-level OR AND gate networks. Statement D, essential hazards may occur in combinational logic network. See, we know 4 different type of hazard, that is static 1 hazard, static 0 hazard, dynamic and essential hazards. Static 1 hazard occurs in AND/OR networks, which can be implemented with product of some expressions, whereas static 0 hazard occurs in that is sum of product expression, that is OR AND network, whereas dynamic hazards occurs in all combinational circuits, not only in OR and AND. Whereas comes to essential hazards, these hazards occur in sequential circuits, not in combinational circuits, hence option A is correct. Why does an FM radio station performance better than an AM radio station for radiating the same total power? We know that in case of an AM radiation, the information presents in the amplitude variations of a signal, whereas in case of FM radio station, the information mainly present in the frequency variations. Here, the noise mainly affects the amplitude variations. It doesn't affect the frequency variations. Hence, FM is more immune to noise compared to the AM. Hence, option A is correct. In FDM system used for telephone, which modulation scheme is adapted? Here, SSB-SC is used for in FDM systems for the telephone, because in case of telephone, here the frequency range is nothing but the frequency range of the voice, whose frequency range is 300 Hz to 3300 Hz. Means there is a gap between the positive and negative frequencies, that is, this is the voice range 0.3 kHz to 3.3 kHz. So there is a gap from the origin, that is the lowest frequency, that is, so 300 Hz, which provides the transition band for the filter design. So there is no overlap in the lower sideband frequencies. Hence most optimum choice is single sideband suppressed carrier. Hence option C is correct. And G of Z are the one-sided Z transforms of discrete time functions f of nt and g of nt. The Z transform of summation of f of kt g of nt minus kt is given by. See, from the above given expression, that is sum of f of kt g of nt minus kt is nothing but the convolution of two functions f of nt g of nt. If it is in time domain, if it is convoluted, then it is in frequency domain or in Z domain, it is going to be, if we apply the Z transform, it is going to be f of z and g of z. According to this one, hence option, according to this one, if we apply the, if we take the z transforms of individual functions f of nt and g of nt, if we multiply those things, we will get option B as the correct option. And question is, the autocorrelation function Rx of tau satisfies which one of the following properties? See, if we look into the properties of an autocorrelation function, see the definition. First of all, we need to look into the definition of an Rx of tau. What is autocorrelation function? Autocorrelation function definition is expectation of x of t plus t plus tau. So, and one more definition is x of t minus t. Okay. So, if we take Rx of minus tau, which is equals to nothing but Rx of tau, means either whether you can advance the sequence or you can delay the sequence in order to get the autocorrelation function. That means the property B is correct, hence answer B is this. Question is, the impulse response of a system h of n, how a and u of n, what is the condition for the system to be Bibo stable? Here, for the condition to be Bibo stable, there is condition for Bibo stable means the h of n must be absolutely summable. Means absolute summability of h of n is nothing but a Bibo stability of a system whose impulse response is h of n. So if we substitute in this one, a n u of n is minus infinite to infinite. If we take u of n into consideration, 0 to infinity, and because u n exists only for the positive n values as well as z equals to 0. So this is possible. This is less than infinite if and only if, because n increases, the magnitude of a is less than 1. Hence option D is correct. Is a system defined by y of n equals to summation x of k from k is from minus infinite to n, where x of k is the causal signal, then the system is an example of. Suppose x of k is the causal signal, means x of k is equals to non-zero for k greater than 0 or equal to 0, and equal to 0 for k less than 0. Okay. Now here, if we consider this summation for any n, suppose y of n naught means we can modify from the above definition. Y of n is k is 0 to n x of k, means for any value of n, it depends upon the past values of x of k. Hence y of n is nothing, this system is nothing but a memory system, it's not a memoryless system. So if we look into the, so it is what it is taking, depending upon the n, it is taking the sum of all the samples up to n, means it is not an averaging system, it is a summer. So hence option B and D are not correct. Comes to invertibility, see, we can write y of n as convolution of x of n into u of n, yes or no? So the z transform of y of n is nothing but x of z 1 minus z inverse. So it is invertible system, because if we multiply, the h of z is nothing but 1 by 1 minus z inverse. So we can get x of z by multiplying y of z into 1 minus z inverse, then we will get x of z back. So this system is an invertible system, hence option A is correct.